So here it is a phasor diagram. IDC and IAC, it is equal to square root of IDC square plus IAC square is your RMS value. So you represent this IRMS is equal to IDC square. Just I am applying a Pythagoras theorem and this is a phasor diagram. So IDC square plus IAC square. So if you write this and square on either side, you get IRMS square is equal to IDC square plus IAC square. So to calculate ripple, what you need is the AC component. So therefore, IAC can be written as equal to square root of IRMS square minus IDC square. So by definition, the ripple factor is equal to IAC by IDC, and that is equal to, by this relation, you can write this as IRMS square by IDC. You take IDC common. So IDC comes out of this integral here as a radical sign square root. So IDC comes out and that IDC gets cancelled with this. You are left with IRMS square by IDC square minus 1 and under the square root. So therefore, it's IAC by IDC and so on. So what you have here, IAC is equal to IDC into IAC by IDC is this much. So IAC will be IDC into 1 IRMS square by IDC square minus 1. This is under square root. There is a square root here. So gamma is equal to IRMS square by IDC square minus 1. This by this, no? IAC by IDC. Square root is missing here. Just write square root here. A same expression can also be written in terms of voltage. So when you write it in terms of voltage, it will be VRMS by VDC. Now substitute the relations IDC is equal to IM by pi or VDC is equal to VM by pi. Now what are you left with? You have to calculate the IRMS value. In the last class, in the physical mode, I think I've shown you how to do the mean square value of the current or the voltage. Have you completed this? Yeah. So the load current is equal to the applied voltage. What was the voltage that was applied? It was Vm sin theta. Vm sin theta divided by the load value, that is RL. But the effective load of the circuit is both RF and RL. Sum of feedback resistance of the diode RF, forward resistance, plus the load resistance. And you are applying the condition that the forward resistance of the diode is very much less compared to the load resistance. Therefore, RL can be taken to be more than RF. RF can be, and hence it can be neglected. So, if it is neglected, you are only left with RL in the denominator. So now what are you doing? IRMS is equal to root, mean and square. So first you must take the square, take the mean and take the square root. So IL square d theta. IL, why am I writing IL? Because it is the load current. Integrated between the terms 0 and 2 pi. Take the average. Average means over a complete cycle. So it's 2 pi. And take the square root. Now, this can be split into two halves. It's a half wave rectifier from 0 to pi and pi to 2 pi. Right? So, and you know that there is no current flowing in this direction from pi to 2 pi. So, you are only left with one half of the interval from 0 to pi. And IL square d theta is represented as Im square sin theta. So it is Im square sin theta So now how do you write this? IL is Im square sin theta. So Im square, I am writing instead of IL as a load current. This is a small letters I have been telling you. The small letters or the lowercase letters indicate the instantaneous values of the current or the voltage. So this is at that instant of time is a load current, which can be written as equal to, as a function of time t, is Im sin theta. So this is equal to Im square sin square theta d theta. Now why am I writing only half interval? Because the other half interval it is just 0. So once again, using your trigonometric relations, sin square theta is equal to 1 minus cos 2 theta by 2. So this is 1 minus cos 2 theta by 2, and this is shown in the brackets here. 1 minus cos 2 theta by 2. What are you getting? The integral of this is theta by 2 minus sine integral cos minus, actually it's plus. It will be plus here, but anyway sine pi is 0. So you are only left with this theta by 2, which is pi by 2. So substitute that here, pi gets cancelled. You have Im square by 4. So Im by 2 is your Ims. So substituting this relation back into the definition of this, it's Im by 2 whole square by Im by pi whole square minus 1. Okay. So Im gets cancelled. So you are left with pi square by 4 minus 1. And substitute the value of pi, which is equal to 3.14, and the square of this, finally take the square root. You are left with this value, which is 1.21. So thus the input factor for a half wave rectifier is given by 1.21.
Ma'am, can you please scroll up?
Up to here?
Yes, ma'am.